So apparently I'm keeping everyone from the coffee break. I thought my presentation. Okay. So the other thing I was told to say was not to make this any sort of product pitch or sales pitch, and I'll get a big clap if I said that. So obviously I'm not going to get a big clap on that. Oh, excellent. Thank you. All right. So quick question before I start. How many people are under a DDoS attack or anything associated? A couple of hands. How many people are aware that they're under a DDoS attack? Okay, so at least the hands are going up. What I have from a first slide perspective is some sort of generic information about what's happening in the marketplace as it relates to DDoS. And there's one particular piece that I want to get to. I mean, the biggest press that you get from a DDoS perspective is when you get something like a 400 gig attack. That's splashed across all the newspapers. That's splashed everywhere that says, okay, so you're getting a full saturation level attack. Typically, what we found in sort of the market that we play in, both fairly globally, is that the full saturation attacks are the sort of the, in terms of how often they occur, it's actually minimal. It's actually the low-end attacks where they're using different mechanisms to attack the network and also the servers and the application. That's occurring in more frequency now. And what's also happening is that the ability for someone to create a DDoS attack or create an attack vector is also increasing rapidly. And I'll get onto that when I talk about that in the next couple of slides. And there are different attack vectors. So, for example, SNMP or SSDP is a mechanism that attackers are now using. For example, there was a recent attack that came out of Canada that hit the UK. Most people are probably not aware of it because the attack was targeted at the NATO summit that was held in Wales recently. So what happened was that the attackers grabbed the cable modems of 3 Canadian operators, and they used that as a vector or that as a botnet to direct that attack directly into the NATO summit. So it's not only, and where do they get that information from? That basically there's a complete list of access on the darknet where you can pick off all the different holes that are available and all the different mechanisms to create attacks onto the network. So, and what attackers are actually inherently doing is that they're not just leveraging attacks to try and pull money out of someone's network. For example, something that's also occurring is on gaming sites. A lot of the gaming sites are being attacked. So, for example, over Christmas, when everyone was buying new games, the PSN network went down. The Xbox network went down. Those were actual DDoS attacks targeted at those specific areas. The recent attack on Sony was a combination of a DDoS attack as well as other infiltration attacks. The one I want to sort of home in on, which is the last point I want to make around this slide, is the fact that one of the attacks that occurred in Sweden fairly recently was targeted at a gaming site. Now, what happened was that even though that single attack went into that gaming site, it took down 3/4 of Sweden's cable infrastructure as well. So a small DDoS attack going into one location has the ability to cripple an entire network on the back of this. And what we're finding is that as the attacks are getting worse or as the attacks are getting more numerous, the cost of clearing up the attack is increasing as well. So, for example, typical data centers, the downtime of a typical data center, 20% of them are due to DDoS attacks, whether they're internal IT infrastructure or whether they're a customer site. Typical DDoS attack, the downtime is 86 minutes on average. The cost of clearing up, for example, I was at a recent conference where the head of the NASDAQ said the cost of actually clearing up or cleaning everything that occurred from a DDoS attack took months and months for him to sort out. Not only does it take your servers down, it also attacks your firewalls, it takes your IPS systems. It has a huge impact on your network infrastructure as well. And so you can charge this directly back to an OPEX and a CAPEX requirement that you're going to have in your business. And the average cost per incident is, and this is in dollars, and you can just do the conversion on this, is about $700K per incident roughly in terms of what can happen because of a DDoS attack. So where are the attacks being generated? Now, basically on this slide and on the map that we've created, volumetric attacks, there are different types of attacks. There are volumetric, there are application-based attacks, there's SYN flood attacks. How many people are aware of the sort of the differences between all of these types of attacks? Yes, no? Okay, good. And they come from different parts of the world. So, I mean, we have the ability to work out exactly what type of attack is occurring, where it's coming from, and the security forensics behind all of that. Now, the key thing around all of this is the fact that as the attackers become smarter, they use different mechanisms to attack your network. They attack the servers, and they use that as a hiding mechanism. For example, I'll go back to the guy from the NASDAQ again who runs their IT infrastructure. What he found was that the initial attack was a volumetric attack that went in. So your security guys will start looking at that volumetric attack. What they then do is behind that volumetric attack, they do a fragmentation attack, right? And it's at a lower threshold than the original attack coming in. So your security guys are busy looking at one particular attack. There's another attack coming in behind that. The third attack behind that is actually a brute force password attack. But you don't actually see the brute force password attack coming in, because all your log files from your firewalls, your IPSs, all of that is actually being swamped by the fact that you're looking at this volumetric attack, which is huge spikes of data coming into the network. Then you're trying to work out what's happening from a fragmentation attack, which is actually targeting the firewall, the stateful firewall mechanisms inside the firewall, and then the servers behind that. Because typically when a firewall or an IPS fail, they fail in line. So the next port of attack is the servers that sit behind all of that. And finally, there's a brute force attack directed at the servers to pull information out of those servers and to actually pull data out of the network. So in terms of what the attackers are now doing, traditionally what the attackers have been doing is saying, okay, I'm going to issue a volumetric attack, so you'll get some 16-year-old in his basement, and they're issuing this. Initially, they were just pushing this type of attack into the network. What they're now doing is 2, 3, 4, and 5 vector attacks. And that's increasing in severity as well. So, for example, as I've sort of just quickly highlighted, the number of vectors that these guys are using to attack your network is increasing. The different types of attacks that are going into the network is also increasing. And the idea is not just to take the network down and not necessarily to actually pull data out the network. For example, we protect a gaming site. We protect a number of gaming sites. And on the gaming systems themselves, what they do is if you play any sort of game on the network, you can buy things on the network. You can buy things for that particular game. They try and hijack the data, they try and take people down, and then they sell the information that they're getting from that. So it isn't just to be honest, they make money on the back of all of that. So it isn't just to take down the network. There are actually sort of behind the scenes of all of this, there's actually a mechanism to make millions and millions of dollars or pounds on the back of everything that they're now doing. And this is just a slide to highlight the different mechanisms and different types of attacks that are coming in, and the nature of a multi-vector attack. So you'll see a high throughput attack, and behind that another attack, and behind that another attack. And as I said, and it's becoming extremely easy for people to generate these multi-vector attacks now. These are just some of the tools that you can now use to generate a DDoS attack. So in the same way, hacking firewalls or breaking firewalls and IPSs became over time extremely easy, generating multi-vector and high-capacity saturation attack is also becoming extremely easy now. So the question is, and let me just bounce through this, the question you have to understand is, are you prepared for the types of different attacks that are coming in? Have you looked at your network infrastructure, and have you considered the different mechanisms? I mean, we've been speaking to a number of people today, and everyone is considering looking at DDoS. But they consider DDoS as the same thing as a firewall or as an IPS. There are different parts of the network that you have to think about from a security perspective and where to put a DDoS system. You also have to look at it from a visibility standpoint. So the solution has not only, if you're trying to stop a multi-vector DDoS attack, you have to understand what the attack vector is, and then what the subsequent attack vector is, and then what the third or fourth of that attack vector is. And you have to be able to work through the system and as well as all the log files to determine exactly what the digital forensics behind the attack is, and then apply a filter to stop that information. And in terms of, finally, sort of the last slide that I want to talk about is where do you put the system? Where would you protect it? So you're looking at protecting your customers. You're also looking at protecting your network itself, and then the customer's customer. So if you're not looking at where these things are coming in and where in the network you have to place these systems, and it isn't just the same as placing a firewall will handle all the DDoS attacks. A stateful firewall will only be able to cope with a certain level of capacity in the system before it fails. You have to be able to put the system or the appliance or the device where the attack is actually coming into the network. That's what I wanted to cover off today. Are there any questions?
Okay, no questions? Okay, well, thank you very much, Bipin.
Thank you.
And